Hello scientists, in this video I would like to show you how to make a pencil and paper graph that shows the relationship between two variables. So to do this you will need obviously a piece of graph paper, a ruler, and a pencil and a calculator. So what you can see here on the screen is a blank sheet of graph paper and a set of data showing how the drop height of a tennis ball affects the bounce height. What these graphs are intended to show is how one variable changing affects the value of another variable. And the first thing you have to do is set up the x and the y axes. In this type of graph, the x-axis is found at the bottom of the graph, and the y-axis goes along the side. And what you want to do first is take your pencil and your ruler and draw a line along the bottom of your graph representing the x-axis and along the side of your graph representing the y. Now, the x-axis is used to represent the possible values of what we call the independent variable. So you want to label that axis with the name of the independent variable and the unit that was used to measure it. And the y-axis is used to show the possible values of the dependent variable. So you want to label that with the name of the dependent variable and the unit used to measure it. And in this case, our independent variable is drop height. Now, we know that the drop height is the independent variable because we chose to change it on purpose. Its value, which you see in the table, 50, 75, 100, 120 by 150, is not determined by another variable. It was just chosen randomly by us. Now, the bounce height, however, the value of that variable depends on the value of the independent variable, on how high you drop it from. So the bounce height is our dependent variable. So to label your axes after you've drawn your lines, all you got to do is write the name of the variable, the correct variable, and the unit underneath the axis, leaving a little bit of space for the numbers you're going to put there in a minute. So there is our x-axis label, and there is our y-axis label. And we're done with the first step. Okay? Now, the next step is determining the scale for each axis. And what this scale is the range of values for each variable that's going to be shown on the axis. So starting at 0, how high are we going to go up for drop height, and how high are we going to go up for bounce height? In other words, what are we going to count each box by? How many centimeters is each box going to be worth on our graph? And there's a series of steps that you can follow to figure this out. And if you do it this way, you're going to get a good scale every time. So you're going to start with the x-axis, or the independent variable. And your first step is to identify the biggest value of that variable. Now, drop height's our independent variable, and you can see in our data table the biggest value for the drop height is 150 centimeters. Then you're going to count the boxes on the x-axis. If I count all the boxes across the horizontal axis of my graph, I'm going to find 18. The next step is just a little math. You're going to divide that biggest value, 150 centimeters, by the number of boxes, like this. If you do that, you get 8.3 centimeters per box. And that's not a great number to count by. And if you use that to figure out your scale, you'd get all the way up to 150, but that's it. You wouldn't have any additional values on your scale. So what you want to do then is round that number up to something that's easy to count by, like 0.5 or 1 or 2 or 5 or 10 or 20. And the next biggest number on that list, bigger than 8.3, is 10. So we're going to round 8.3 up to 10. That means we're going to count by 10 centimeters per box on our x-axis. And what you'll do to show that each box is worth 10 centimeters is right on the line, on the right side of each box, you're going to start with 10 and count by 10s all the way across the axis. So 10, 20, 30, 40, 50, 60, and then and all the way up to the end of the axis. Now you can see the x-axis now shows a scale from 0 to 180 centimeters for drop height. And that's great. Our biggest number is 150. That'll fit on there perfect, and we're going to use up most of our axis with our graph. All right, that's how you determine the scale for the x. And it's the same thing for the y. You're going to follow the same series of steps, find the biggest value, count the number of boxes, divide and round up. And if you do that for this particular set of data in y-axis, you're going to get a number around 3, and you'll round that up to 5. And you'll count by 5s on your y, just like that. And that's how you figure out the scale. All right, next step. Once you've got your axis set up and your scale written on each axis, you are going to plot your points. Also note that that left-hand bottom corner is always going to be 0. Plotting points is actually getting the value of the independent variable and the corresponding dependent variable on your graph as a point. And we call these points XY coordinates. And what an XY coordinate is just the independent variable value and the dependent variable value written together inside some parentheses like this. Okay? So you take your independent variable and your dependent variable, which for our first drop height or independent variable is 50. And when we drop it from 50 centimeters, we got an average bounce height of 23. And to get the XY coordinate, we write it like that. Now, writing the values of the variables as XY coordinates really just makes it easier for you to get those points onto the graph. As you become more familiar, you can skip this step. But for now, I want to make sure you do it. So we take 75 and 33, we write it like that, 148 like that, 125, 57, and 150 and 74 like that. Each of those XY coordinates shows a drop height and the bounce height you got when you dropped it from that height together. Okay? Now, to get those onto your graph, here's what you do. We're going to start with 50 and 23. You're going to go across your x-axis until you get to the value you're interested in for drop height, which in this case is 50. You're going to go straight up until you're at the point level with the value of the dependent variable on the y-axis. So we're going to go straight up from 50 until we're at 23. And we're going to write a point right there. So over on the x to 50, straight up 50 until we're level with 23. And that's our first point. And we do our second one. Over on the x to 75, that's our drop height. Straight up from 75 until we're level with 33 and put another point there. And we continue for 148, 125 and 57, and 150 and 74. Now, what we have shown here is visually described how, as we increase the drop height by 25 centimeters each time, how the bounce height increases as well. You can see it going up as more or less a straight line. All right? That's how you get your points from your data onto your graph, showing how changing one variable affects the other. Next step, the line of best fit. Now, this is a really simple step, but it is probably the most important because it actually gets you the line or the representation, the visual representation of the relationship between those two variables. And as we'll see later, looking at the shape of the line and what the line is doing tells us a whole lot of information about how the two variables are related. And for a graph like this, it's pretty simple. You're going to take your ruler, and since we know when there's 0 drop height, we have 0 bounce height, you're going to start at 0, 0 down in the bottom left corner, and you're going to draw a line that comes as close to as many of the points as possible. And it's not going to hit all of them, unless you've got perfect measurements, which almost never happens. It'll hit some of them maybe, and some of them will be on either side of the line, like this. You're essentially creating a visual average, right? You see how we have that one point in the middle and the one at the either end touching the line, but then there's a couple that are a little bit off to the right. Perfectly fine. Okay? So it's that line that tells us or shows us visually how bounce height changes as we change drop height. Last step, before you're done, you're going to need a title. And the criteria for the title is simple. It just has to include the names of both variables. And one classic title is just to say the effect of the independent variable on the dependent variable, or in this case, the effect of drop height on bounce height. There you go. That's a nice scatter plot graph that you can use to model the relationship between drop height and bounce height for a tennis ball. Hope that helps.